In this video, we're going to start talking about some of the properties of quadratic functions. The first thing I have here, if you notice, is comparing the transformations on the x squared graph to, the x squared function to these transformations here. So the first thing I want you to do is pause the video for a moment and try to note what has happened to these functions as it compares to our original x squared function. For example, in this first one, I would say that inside of here, this is going to be my horizontal shift of 2 to the left. Remember, when it's positive inside, it means we're going the opposite direction. And this one is going to talk about a vertical shift down 5 units. So pause the video and decide what it's going to be for h of x and g of x. So as you can check yourself, hopefully you see that, again, the outside of the function in this one here is going to be up 3 units. This one is going to be up 2 units. Inside, we're going to be to the right 4, and this here indicates that we're going to be flipping over the x-axis or reflecting. So then the next thing I want you to do is putting in everything else into the tables. And it might help to go into Desmos and help you out to figure out what part or what side of the the y-axis you want to start with. So I have this plugged into Desmos, and that's going to help me create my table. If you'll notice, we have that my vertex is down here at -2, 5. So I can put that value in. I'm going to put that right there in the -5 column. And as I notice, as I go, I'm going to change my x's to be one less going this way and one greater going this way. But what I also want to notice is that it's the same progression. We didn't do any kind of stretching or shrinking horizontally or vertically. So it's going to go over 1, up 1, and then over 2, up 4. We're going to follow that same progression. So over 1, up 1. So now I'm going to be at -4 on this side, on both sides actually, because they're going to be symmetric about their axis of symmetry here. And then it's going to be over 2, up 4. So I'm going to be here at -1 and -1 here. So let's look at the next one. So as we do this one, if you'll notice, that now we have this reflecting over. We're going to start at the vertex, which happens to be at 0, 3. So I'm going to put that one in the center. And then we're going to go over 1, and this one is reflected, so it's going to go over 1 and down 1. And it's going to be 2. They're going to be symmetric again. And then this one is going to be over, so we got -1, 1. So we -1, -2, and then we've got 1 and 2. And then we're going to go over 2 and then down 4. So this one is going to be down here at -1. So all of them are going to. So once we've got this plugged in, then we're going to look here and say, oh, well, the vertex is at 4 and 2. Then again, I'm going to go 1 lower on each side, 1 higher on each side, and then I go over 1 and up 1. So I'm now at 5, 3, and it's going to be symmetric. Then I'm going to, from my point, I'm going to go over 2 and up 4. So I'm now at 6, which is 4 higher than the vertex. So let's look at all of these put together. The first thing when graphing the quadratics is that same pattern, again, over 1 and up 1 on every parabola. But the other thing I want to point out now is my vertex and how it relates to the values in this particular form. So when we're looking at this, when I have 2 and -5, I now have -2 and a -5. When I have nothing added to my x, then the vertex, the x component is 0. And when I have 3 added to my y, the vertex is 3. Or the y component of the vertex is 3. When I have -4 and 2, my vertex is 4 and 2. So there is a very direct relationship between these values. The value added to x, the opposite, is going to be the x value of the vertex, and the value of the y is going to be the exact value. And so it comes from that x minus h squared plus k format, where again the h, or the opposite value, is the value of the x component of the vertex, and then the k is the y component of the vertex. So every time we try to read this out, we are going to take the h and the k and start with the vertex. So let's look at the next set. So from this, we can probably already guess that this is my h is going to be 1, my k is going to be 2. And then I'm going to go, again, we're going to go 1 less, and 1 less, 1 more, and 1 more. So it's going to go over 1 and up 1, over 2, and up 4. So I'm going to be 4 bigger than my vertex. And it's going to be symmetric. So let's check that out on Desmos and make sure I'm right. Now when I put this in on Desmos, it doesn't look quite right, and I can even check the table. If I hit on that little gear, I can check the tables, and it went the other way because I didn't remember to take the fact that it reflected. So instead of going over 1 and up 1, it went over 1 and down 1. So I have to make sure I take that into account as well. So let's fix that real quick, shall we? So that looks much better. And again, I have my example there on Desmos rather than sketching the graph in. So let's do this again on this graph, going over. Now we have something that's going to get a little bit bigger. So let's look at what it looks like with that stretch taken into account. So let's modify this. So now we have it going over 1, but up twice as high. So we have the vertex here, but it's at 0, 1, and this is what we would expect. Again, when there is no no horizontal motion, but there's a vertical movement down. So when x is 0, y is negative 1. Instead of 0, 0, the vertex goes down 1. But now we go over 1 and up 2. So here we've gone over 1 and up 2. So when we go over 2, we go up 8 from the original. So 2 goes up to 7. It's 8 higher than my vertex. Remember, this is my vertex here. But if you'll notice, the stretching and the shrinking does not change the location of the vertex. My vertical shift and my horizontal shift was 0, so it still stayed at the x value of 0, and my vertical shift was down 1. And again, it's symmetric, so I go 1 lower, 1 lower, and this also becomes 1 and 7. Moving on to one more. Look at all this. So we have here, I know that my vertex is going to be read right out of this, so this is going to be a horizontal shift to the right. So this is going to be my x value. This is going to be a vertical shift up 2, so that's going to be my y value, so 4 and 2. But now we've got a horizontal shrink, so we're shrinking down by half. So it's over 1, so I'm going to still count up and count down, but try to predict where it's going to go. Now it's going half the distance. So let's put that in and see what that means. So let's put that in. So we got 0.5, got x minus 4, oops, not 400, over, and we've got plus 2. So first of all, our vertex is where we thought it would be, right there at 4, 2. But then when we go over 1, I go up only a half, but a half higher than this one. So this is at 2.5. So I went over 1 and up a half. So usually, remember, parabolas x squareds will go over 1 and up 1, over 2 and up 4. But this is going half the distance, so it's going over 2 and up 2, or 2 higher than the y value, which is 4. And again, this is symmetric. But the question comes up, what if it's not in vertex form? We have two solutions of that, actually. The equation is the one that I gave you recently that said, we have our x minus h squared plus k, where again, the h and the k can be read directly out of it, and we can find the vertex. Let me make my f of x. But in this case, this does not have any binomial squared or things added on the end, and I'm not quite sure what to do with it. Well, here's the other solution. we can take the b, negative b over 2a, that's my x value, and then plug it in to find the y value. So what is b and a and all that good stuff? That goes back to the same thing as the quadratic formula. So this is a, this is b, and this is c. So doing this, first of all, is it going to be a maximum or minimum? Hopefully we know by now that when we have the negative in front, that means it's going to go from an upward facing parabola to a downward facing parabola. So this is going to be a maximum. So this is going to be a maximum value, this vertex. If it was positive, then it would be here and it would be a minimum. But we have a maximum value. So we know this is going to be it. So what we have to do is we have to put in this formula. So negative b over 2a. So when we put that in, this becomes negative 8 over negative 8, which becomes 1. So that is going to be my x value of the coordinates of the vertex. And then we have to put that value 1 back into my equation. So that's our f of 1, excuse me, f of, oops, let's take that out, shall we? So that's f of 1. That's the x value we found. And that is negative 4 times, I'm just putting 1 in, finding out what that function value is at x is equal to 1. So this is negative 4 plus 8 minus 3 is equal to a positive 1. So my vertex is at 1, 1. So on these next two, I want you to find the vertex of it using your negative b over 2a. So remember, this is a, this is b, and this is c. This is also a, b, and c. Okay, so putting these values in, we decided to find the x value, which we calculated to be 4, which is what's here, and then we did f of 4, which became 1, and that was our first vertex. And flipping it over into Desmos, we see that this red graph here is, in fact, at the vertex of 4 and 1. Doing the same thing over here in this graph, we put the a and the b and 2a in here. We got negative 1. And then putting that f of negative 1, we found again that our vertex was negative 1, negative 1. So putting those values in, and again confirming on Desmos that in fact it is negative 1, negative 1. So now the vertex form of the equation, what we're going to do is we're going to go backwards on this. We've been pulling it out of this equation. Let's put it back in this equation. So f of x is equal to, well, x minus 4 squared. Because remember, the one inside the parentheses is the opposite of this value here in the vertex. Then plus 1. This one down here should be f of x is equal to x plus 1. Remember, again, it's the opposite on the inside with the x value, and then minus 1. So let's expand vertex form, shall we? So let's do this. We're going to expand my binomial, so that's x minus 4, and then we'll add 1. So this becomes x squared minus 8x plus 16 plus 1 more, which, hey, ends up to be exactly what I started with right over here. Doing the same thing again, if I expanded out my binomial here, oops, let's put it in the right spot, shall we? Let's put it here, and x plus 1, and then we subtract 1, so I've got x squared, and I forgot the little negative inside first. So let's get that whole thing put there. So we got x squared plus 2x minus 1. We got the negative out front, minus 1. So let's distribute that through. And we have negative x squared minus 2x plus 1. That should be plus, which would make this one minus. There we go. Minus 1, which again comes to x squared minus 2x minus 2, which again is this formula we started with once I had that little computational error. So that's the point. Whether we find the vertex from reading it out of the vertex form of the equation, or we take the standard form of the equation and calculate the vertex from there, you can find the vertex in two different ways. So let's talk about one more function in terms of completing the square to find the maximum and minimum. So again, we know this is going to be a minimum because the lead coefficient here is a positive 1. So we know it's going to be a downward, or excuse me, an upward facing parabola. So this bottom point is going to be our minimum. But let's calculate this all. So the first thing I want to do is, again, do some review. Let's do that negative b over 2a and the function value of negative b over 2a to find the vertex. So do that first. I'll pause the video. So in finding negative b over 2a and then the function value of that value, which is 4, we find the vertex is at 4, 4. So I could absolutely put that back into the standard form, excuse me, the vertex form of the equation, and simply write, this could be written as x minus 4 squared plus 4, and that's the vertex form of the equation, again using these two values. But let's find one more thing. Let's use completing the square to find that maximum minimum. So we've got the function value, and I'm going to turn it into the vertex form of the equation. So I've got x squared minus 8x, and what I'm going to do is I'm going to put the 20 over here, and let's do the good old completing the square. So when we do that, remember we cut it in half, and we square it. So I know my binomial is going to be x minus 4. But here's what's different. When we completed the square when factoring or when solving quadratics, we would add it to the other side over here. But that doesn't really help us because we're trying to keep everything on the one side. So what we do is whatever we add to the function, I also subtract from the function on the same side. So you know, if we combined all my like terms, all of my red and black, then it would all combine to be the same value. Excuse me, the original function. But what I'm going to do is this 16 has helped create my binomial here, my binomial squared, and then this one I'm simply going to combine, and I'm going to get plus 4 on the outside, which is what we got when we put our vertex directly into the vertex form of the equation. So there's so many different ways to do it. We can solve it by doing the negative b over 2a to find the x, then the function value of that x. We can do it by completing the square to find the function, or excuse me, square to find the vertex form, or hopefully we're lucky enough to just get the vertex form. So these are all different ways of finding the vertex in a quadratic function.